In this video, we're going to talk about applications of exponential and logarithmic integration from section 5.3. The suggested problems for this topic are numbers 51 through 56 all. And I'm just going to cover the odd number problems in that section because these are all multi-part application problems, and I want to keep the video a little shorter, give you a couple problems to try on your end so you can try the even number problems after you see me do the odd number problems. So let's start with number 51. And it's a biology problem. A population P of bacteria is growing at a rate of dP dt is equal to 3,000 over 1 plus 0.25 t. So dP dt is the change in population over time, and this is the rate of change here. We're going to solve this by separating the variables, putting the dt over on the right with the function of t, and we get dP is equal to 3,000 interval of 1 over 1 plus 0.25 t in the denominator. Dt, that 3,000 just pass through the integration symbol. I'm going to go ahead and multiply in the top by 0.25, divide by 0.25 on the outside. That's the same as multiplying by 4, since 0.25 is the same thing as 1/4. The reciprocal of 1/4 is 4. So integrate this side, I get P of t, and that's going to be 12,000. And then that's going to be ln of the absolute value of 1 plus 0.25 t plus c. We were given the initial condition here that t of 0 is equal to 1,000. Now we're ready to use that to say P of 0 is equal to 12,000 ln of 1. 1 plus 0 is 1, plus c needs to be equal to 1,000. ln of 1 is 0, so this whole thing is 0. So c is equal to 1,000. That makes P of t equal to 12,000 ln of the absolute value of 1 plus 0.25 t plus 1,000. Since my t values are always greater than or equal to 0 here, since we're talking about time, I really don't need absolute value bars here. I'm just going to leave them anyways, though, since that's part of your formula. So this was part A, was to find the model for the population, and I'll leave it just like that. Part B says to find the population after 15, after 3 days. After 3 days, so P of 3 is 12,000 ln of 1 plus 3 times 0.25 is 0.75 plus 1,000. You can pop that into your calculator, round to the nearest whole number, and you're going to get 7,715, and these are bacteria. And the question is how much time has to pass for there to be 12,000 bacteria in the population. So 12,000 is equal to 12,000 ln absolute value 1 plus 0.25 t plus 1,000. So this is 12,000 ln of 1 plus 0.25t, switching sides of the equation here, plus 1,000 is equal to 12,000. Just want my solution to be on the right. Subtract 1,000 from both sides. 12,000 ln of absolute value 1 plus 0.25t is equal to 11,000. Now we're going to divide by 12,000. We get ln of absolute value 1 plus 0.25t is equal to 11/12. So 1 plus 0.25t is equal to e to the 11/12. 0.25t is equal to e to the 11/12 minus 1. Multiply by 4 on both sides. T is exactly equal to 4e to the 11/12 minus 4. Pop that into the calculator to get an approximation, and we get approximately 6 days pass for the population to reach 12,000 bacteria. All right, let's move on to number 53. Number 53 is a business application on demand. So dP dt, sorry, not dt, dx. So this is how the price changes as the demand changes, is equal to 0.1 e to the negative x over 500. So the first question, let's finish this up with the initial condition that's given to us, that P of 600 units, when 600 units are demanded, the price of each unit is $30. All right, find the demand function. So dP is equal to 0.1 e to the negative x over 500 dx. We're going to integrate both sides to get P of x is 0.1 e to the, so I need 1 over 500 here, and I need times 500 out here. So that's going to be 50, and this is negative, that's negative 50, e to the negative x over 500 plus c. P of 600 is equal to negative 50 e to the negative 6/5 plus c, and that needs to be equal to 30. So c is going to be 30 plus 50 e to the negative 6/5. Go ahead and approximate that to 2 decimal places in your calculator. Since we're talking about a price here, this needs to be in dollars and cents. So that needs to be 45.06. So we'll put that back in place of C in our general solution to make our particular solution here. Negative 50 e to the negative x over 500 plus 45.06. Don't put the dollar sign there. Now our question for part B says what use a graphing utility. We don't need to use a graphing utility. We'll just talk about this. Use a graphing utility to graph the demand function and does the price increase or decrease as demand increases? So as X increases, what's happening to P? So we have a increasing at a decreasing rate here. So our X versus P here, that price is going to go up significantly. Let's see if I have a minimum price here of, can't quite get to this piece being, see, demand is 0 there. So I need minimum demand, it's -50, -5. So it's kind of a boundary down there. And it changes drastically here. And then it's kind of increasing, but at a decreasing rate. You can graph this in your calculator to see that, but it's still always a positive slope from there. So this is increasing. And the way that I know that it's increasing is this exponential function here, even if it is going closer to 0 from above like this, as I go to the right, this is a positive, this is a positive times a positive is always positive. My slope is positive, I'm increasing. Part C says to use the calculator features to find the quantity of demand when the price is $22. I'm going to do that by hand with you. I'm not going to use the calculator for that. So I think the teacher would prefer that you know how to do that by hand. Just use the calculator to do the arithmetic. So if the teacher wants to show you how to use the graphing calculator to do this, I'll let the teacher do that in class. So we want to take our equation here. We want to set that to $22 for the price. So when I subtract 45.06 from both sides, I get -50. E to the negative x over 500 is equal to a negative 23.06. And then I divide, I get 0.4612. And then I take the natural log of both sides. And then I multiply by -500. And I round to the nearest unit of demand. And because I have to have whole units that I sell, I can't sell a fraction of a unit, and I get 387 units. All right, so that means that somewhere out here, there's approximately a point of 387 and 22. That's approximately what's going on there. So I told you, find the horizontal line, P equals 22, find where it crosses the curve, and it's about at 387 units. All right, let's go ahead and let's look at number 55, which is a revenue problem. says the rate of change of revenue for the Priceline Group from 2004 to 2013 can be modeled by dr dt is 0.07 e to the 0.2387t. Oops, 7t. There we go. And we're told that in the year that t is the number of years after the year 2000. So 2004 would be represented by t equals 4. 2013 would be represented by t equals 13. We're told that r at 2013 is 6.8, where r is measured in billions of dollars. Yeah, billions of dollars. R in billions of dollars. That'll be important when we label our answer at the end. Okay, so separate your variables. dr is equal to 0.07 e to the 0.2387t dt. Integrate both sides. R of t is equal to 0.07. Let's see, we need to have a 0.2387 here. We divide by 0.2387 here. So 0.2387 e to the 0.2387t plus c. Let's clean that up a little bit. And once we put our numbers into our calculator here, we want this to be 0.293 e to the 0.2387t plus some constant. And we're going to take 6.8 and this is 0.293 e to the, and when I multiply by 13, 0.2387 times 13 is 3.1031. Go ahead and don't forget your plus c here. So c is equal to 6.8 minus 0.293 e to the 3.1031, and c is going to be approximately 0.276. We're going to go to 3 decimal places there. So that gives me my r of t is equal to 0.293 e to the 0.2387t plus 0.276. Again, remember r is in billions of dollars. So now, let's see, this was part A. Part B asks me to find the revenue in 2012 based off of this model. So find R of 12. It's going to be 0.293 e to the 0.2387 times 12 plus 0.276, and put that in your calculator. Round to the nearest tenth of $1 billion here. So this is $5.4 billion. There we go. That's it for this video. I think you see why I only did 3 of the problems here for you in this video and left the other couple problems for you to do on your own. Go ahead and try them out. Ask your teacher if you have any questions. But next time when we come back, we're going to talk about section 5.4. So see you for the next video.